So today and tomorrow we're going to talk about angles. We're going to talk about naming them as specific today and measuring them with protractors. You don't need your own. I have them. So we're going to start first, just like we do with segments. There will be a protractor printed. We'll do that one today, where it's already printed. You just have to read it. And then tomorrow I'll hand you a protractor, and you'll have to find the measure of stuff. Let's talk about angles in general first. Your first blank, and I'll explain it afterwards. Your first blank, an angle consists of two different rays with the same endpoint. At the top of this page, yep. An angle has two different rays with the same endpoint, or start point, or initial point, like it says. Two different rays that have the same initial point, or same start point, same end point, however you wish to name it. Two different rays that have the same end point. So in this angle, what are the two rays called? AB and AC, and their end point would be A, right? So what you're going to write next says sides of the angle. What did we just say the sides of the angle were? They are, and they are called rays. That's all. You're just going to put that they're rays. The sides of the angle are rays. Rays. And then the vertex. Which of these is the vertex? A. So you're going to write two things, and one of them you'll highlight. You'll need 3 highlighters today. 3. An angle's vertex, it's that endpoint, or the common endpoint. That's the first thing you're going to write. The vertex is the common endpoint. The vertex is the common endpoint. What I really want you to write and highlight, it was the common endpoint, that's what you wrote. What I want you to highlight is that it's the corner. So the vertex is the corner. And that's what you'll highlight. Vertex is the corner. The first thing you wrote was that it's the common endpoint. What you're going to highlight is that it's the corner. The vertex is the most important part of the angle. It's how you name an angle. Okay, so here the vertex is A. I would like you to draw this angle off to the side. You've got like a big blank section next to the more complicated angle. Go ahead and draw it off to the side. So you're drawing this off to the side. We're not on this. We're on these are those. So we are drawing an angle off to the side with B, A, and C. Let's see if you pass the normal people test. You ready? How did you draw it? Did you start with B, A, or C? Wonderful. You're normal people. So normally when you draw an angle, you draw like that, B, A, C, or you would draw like that, yes? That's actually how you name it. When you name it, you're going to put the symbol first. It kind of looks like a less than sign, but this bottom portion is horizontal. It's flat. So go ahead and draw angle. And then you name it like you drew it. So you started at B and then you did A, C. So that's one way to name it, B, A, C. The other way to name it, you could have done C, A, B. C, A, B. You what?
It can be ABC.
It cannot, because we don't draw it that way. A, B, C, I'll show you. A, B, C would mean that the vertex was B. Because what you're going to notice is that center letter is the vertex. And there's one more way to name it. You can name it solely with the vertex. You could say angle A. So the vertex will always have to be in the center. So that's why we couldn't name it that way. So it's just going to pop up again. BAC, CAB, and angle A. The vertex is either in the center or it's the only thing you name the angle. All right, simple enough? This is why you have 3 highlighters. We're going to name, how many angles are there in this picture?
3.
There's 3. Right? There's the 2 inner, and then what? There's the 1 outer. Right? Go ahead and take a color of your choosing. We're going to do the inner top angle first. Try to make sure you're highlighting on the inside of it. because we're going to have 3 colors here eventually. So we have highlighted the top angle. So anytime you name an angle, you're going to write the angle symbol. All right? There's actually only 2 ways to name this angle in particular, and I'll explain why. One way we could say is PQS, PQS, PQS. And then if we could say PQS, what do you think the other way we can name it is? SQP. Do you remember the other way to name an angle? Remember what it was? It would have been Q. Can someone take a stab at why we cannot name this angle Q?
Because there's another line.
Yeah. There's 3 angles with the vertex Q. We would have no idea which one it's referring to, so none of them get named angle Q. You have to use 3 letters. Okay, so we know this is PQS, SQP. You can take a second color. We'll name the bottom. Look at that. It's not bad. So we highlighted the second portion.
So if the R line wasn't there, we could name it
Q.
Q?
Yes, correct. He was just saying if it was just this, could we name it Q? And you could. Well, we got 2 angles. 3, actually. All right, so angle, we can say SQR, or we could say angle RQS. And then the last is the very outer angle. The very outside angle. And we would name this one PQR, or we could reverse it to RQP. This slide is not on your notes. It's just we have to say it out loud so that we're all on the same page. They're just words that you probably already know what they mean. If I had a point on the angle, that means it's on the angle. We good? If I had a point on the interior of the angle, where do you think it'd be located? On the inside of the angle. That's interior. And then last, if I had a point on the exterior of the angle, that means be on the outside. All right, so it's not on your notes because, yeah, we just have to say it out loud so that we all know what these 3 words mean. All right, we're going to do our first example, similar to what we just did. A lighthouse keeper measures the angles formed by a lighthouse at point M and 3 boats. We're going to name all the angles made. You don't have to name them multiple ways. We're just going to name 3 angles. All right, so let's start. We'll start with the top angle. All right, what would we name the top angle?
JMK.
Angle JMK. So again, you don't have to name it all the ways, just the one time. That's good. The bottom angle?
KML.
Correct. Angle KML. And then the outer angle?
JML.
Angle JML. Jamal. That's it. When you're ready, you can turn the page. We're going to come back to this in a second. You'll flip to the practice, but we're going to do one more thing before we do. We're going to talk about protractors for a second. Can anybody take a stab at what they think this little m means?
It's the name of the
part of the formula. So
There's no formula.
oh,
I'm going to tell you, yes. Measure. M means measure. All right? So this would read as the measure of angle A. All right? The measure of angle A. So what you're going to see is a protractor. This protractor is how you measure angles. An angle is a pivot. How much something pivots. If I pivoted all the way around in a circle, that is how much?
360.
360. For the purpose of this class, we don't do anything above 180, but they do exist in real life. If you've ever seen a skateboarder or a snowboarder, they do like 720s and like random stuff. Those exist. We know they exist. But in this class, we're doing 180 or less. Okay? The same thing with positive numbers or positive angles. We will only have positive angles. They do exist in like upper maths, but not here. Positive angles, just like you have positive segments. All right, so if a whole circle is 360, why is 180, because I know it's blurry, but it's on this protractor, why is 180 special? Because it's half of a circle, all right? So here's what's going to happen. Part of this has two rows. The top row, let's say it starts at 0, and it goes 10, 20, 30, 40, 50, 60, all the way to 180. I know it's really blurry, but you're going to see one tomorrow as well. And then the same thing with the bottom, except for 0 would be over here. And it goes 10, 20, 40, 68, all the way to 180. Because this amount of pivot is 180 degrees. And this is what we would use to measure an angle. All right? Ms. Marshall, how do I know which row to use? It does not matter which row you use as long as you are consistent. So you have 2 rays, yes? Mm-hmm. Right, Mike? 2 rays? On this picture, one of the rays is this blue, it's CA or AC, and then AB is also another one of them. Whenever you read a protractor, you just need to read the same row for both of them. So let's say for this first ray, let's read the bottom row. What is this ray at on the bottom row?
0.
On the bottom row, that'd be 0. And then the other ray, we would also need to read the bottom row. I know it's super blurry, but what number is that? 50. It's 50, that's 40. 10, 20, 30, 40. It's 50. So what's the distance between 0 and 50? 50 degrees. You would do the same thing with the top row. What number is on the top row of AC? 180. Right, I know that's super blurry, 180. What number is on the top row up here? 130. What's the distance from 180 to 130? 50. How'd you know that? You subtract. So it doesn't matter which row you read, you're still going to get 50 as long as you read the same row. So top row, or bottom row, you'll get the same answer. Okay, you answer in degrees, so the measure of BAC was 50 degrees no matter which row you read. All right, this is just saying you can subtract to find out the measure of an angle. All right, then the last thing before we actually do it is classifying angles. At the top, you'll see 4 pictures. We should know these names. What is an angle between 0 and 90? Acute. It's so cute because it's so small. Between 0 and 90 is called acute. That's first blank. What if an angle is 90? It's a right angle. What if an angle is above 90 but less than 180? It's called obtuse. And then last, if an angle is 180 degrees, straight angle. Make sure you say straight angle. So make sure you know the difference between measure and length. All the straight lines in this classroom are 180 degrees, but they are not all 180 feet or 180 inches. It's not the same thing. So like this part of my board, we all see it? Okay. This is 180 degrees, but it's probably like 4 feet long. So make sure you know the difference between degrees and the length. They're not equal to each other. Okay, we'll talk more about it as the year goes on. All right, so we're going to use this protractor to find the measure of a bunch of stuff. We're going to start with AOB. AOB. What row do we want to read? I think I'd rather read the bottom row. Can anybody tell me why? It starts at 0, so it's really easy to read. Starts at 0, which means you need to read the bottom row for the other angle as well. It's halfway between 30 and 40. 35. So this would be 35 degrees. What kind of angle is that? Acute, right, or obtuse?
Acute.
It is acute. Then we have AOC. It's the same idea. The bottom row is 0. So let's read the bottom row. So this ray OC is halfway between 60 and 70. So 65. So the distance from 0 to 65 is 65, which makes it acute. Then we will have BOC. Your answer should also make sense. If we look at this, does this look like an obtuse angle that we just highlighted? It does not. So if we got a number above 90, we would know we were wrong. So we can pick a row. We've been doing the bottom row. We might as well. What's halfway between 30 and 40?
35.
35. And then halfway between 60 and 70 is still 65. So then how do I find the measure of this angle? Subtract. What is 65 minus 35?
30.
It is 30, which makes it acute. I'm just writing on the board what we've already figured out, so we don't have to keep doing it. We've done all of these, right? We had 65. This was at 65 degrees. This one was at 35. This one's at 0. So we're just going to read the bottom row because it's just easiest. BOE. BOE. So B was at 35. OE is at
145.
correct. Remember, we read the bottom row. Okay, so 145. So go ahead and subtract them. What is 145 minus 35? 110, which makes it obtuse, which made sense. Here's what you can use as a reference. You can always use 90 as a reference. What on your literal desk is 90 degrees? The corner, even easier than that. What else is 90 degrees? The corners of your papers are all 90. So you could always use them. You could always use the corner of your paper and line it up with the angle. This is 90 degrees, which means this is way bigger than 90. Okay, so you could always use the corner of your paper. Yes, sir? Yeah, go for it. All right, so then we have COE. COE. So we said OC is at 65, and OE is still at 145. So go ahead and subtract them. What is 145 minus 65? 80, which makes it still acute. COD. So C, the bottom row is 65. OD, the bottom row is 110. So what is 110 minus 65? It is 45, which makes it acute. All right, then we get BOD. So again, we had 110 on the bottom row. Then we have 35 on this bottom row. Go ahead and subtract them. We get 75, which is acute. And then last is AOE. A is still at 0. OE is still at 145. So then the measure of AOE is 145, which makes it obtuse. All right, so you're actually going to go to the 1.5 practice, and you're going to do the first 3. I'll walk around and try to check as many as possible. So on our notes, we're on page 3. All right, actually I lied. Sorry. So like 2 years ago, I had all the terms on the front page, and I hated it, and students hated it, and I thought I corrected them all except for this one. So this word, these words are on the front page, and I'm really sorry. Then you'll go to page 3. Now, congruent angles are angles with the same measure. So on the first page, they're angles with the same measure. Angles with the same measure. Now you can go back. It's obnoxious. I'm so sorry. Angles with the same measure. So here's what you're going to write in the first box. Remember, what did this little M mean? Measure of angle. And then what can we name this angle? What's the simplest way we can name this angle? Angle A. I mean, that's not wrong. You could say BAC or CAB. All right, but the measure of angle A is 50 degrees. The measure of angle E is 50 degrees. Why did we write this, Ms. Marshall? Because I'm going to have you write a different statement. You wrote those two? All right, that means angle A is congruent to, what does the congruent symbol look like?
Squiggly line and then equals.
Squiggle with an equal. And angle A is congruent to angle E. That was the main goal. And we wrote that. I've seen a lot of different variations of the congruent symbol. It's only one wave. I've seen that, and that's just scary.
I've seen one with just two.
Yeah. You what? That's equivalent.
Oh.
Yeah.
I did that on my quiz.
All right, so now we're going to talk about congruent angles. You remember on segments, how did we know? Ooh, can I at least make it look like they're congruent? How did we know that they were congruent?
Same measure.
Yes, they had the same length, but how did I know they had the same length?
Oh, because they have the dashes.
They had the dashes. So you're going to look for the equivalent on an angle. Can anybody guess what the equivalent is for angles?
The loops.
They're going to, yeah, we call them arcs. So if you look, G has one arc. This angle also has one arc. That means that they'll be the same measure. This angle has two. This angle has two. That means that they will also be the same measure. So in this first question, when it says identify the congruent angles labeled in the quilt design, that's what we're going to do. Let's start with this one arc up here. Can I call it angle G?
Yes.
I can. There's only one angle at this vertex that would have G. So that's it. Angle G. And it is congruent to this angle with one arc as well. What can I name that bottom angle? Angle B. Great. And then now we have angles with two arcs. Let's go ahead and name this one with two arcs. We could say angle F is congruent to angle D. That's it for that part. All right, the bottom, they said the measure of ADC. What is the vertex of ADC? Which of those letters is the vertex? D. So whenever you see that, the vertex is 140 degrees. ADC. ADC. Hopefully you can see it in one of those colors. There's way too many colors. Right here. All right. And then it says, what is the measure of EFG? What's the vertex of EFG? F. So that means this angle, where F is the vertex, is what we're trying to find. What do I know about these two angles, about F and D? They're congruent. They have two arcs, which means they're the same measure. So what is the measure of EFG? 140. So you're going to list it. The measure of angle EFG. And it equals 140 degrees. That's it. We will come back to this, but we're going to math first. All right. If you remember the segment addition postulates, okay, if you don't remember those words, but you remember the concept, give me two numbers. 12 and 15. If these two segments were 12 and 15, what was the full length of the segment? 27. How'd you do that? 12 plus 15 made 27. It's the same thing with angles. Let's say this was, give me a 51 degrees. And this angle was 32 degrees. Are you reading that from somewhere? I feel like that's an example somewhere. It's fine. What would the measure of the outer angle be? All of it. 83, you'd add them. All right? It's the same property. So I'm going to have you write down the first blank at the bottom. If P is on the interior, It's going to go into a bunch of letters. You remember AB plus BC equals AC? It looks more complicated with angles. So here's what we're going to write. We're instead going to write the inner angle, which is this angle. The inner angle plus the inner angle, which is this one, equals the outer angle. So the inner plus the inner equals the outer. And that's what we'll write. That's what we'll say. Because it's just less complicated, I'll show you. They put the measure of RSP plus the measure of PST equals the measure of RST. It's not very memorable. Then they give an example. If RSP is 36 and PST is 38, what would I do to find the measure of RST? Add them together. And 36 plus 38 makes? 74. Look at that. Going to go to the next page. This is the last thing we learned together today. Good. Find the measure of JKL. Is this an inner angle or an outer angle? It's the outer. So what are we going to do with the two inner angles? Add them. 31 plus 85. Whoop. Correct. Equals 116. So the measure of angle JKL equals 116 degrees. Five, it says the measure of RSU is 91. Is that an inner angle? That's the outer angle. That means both of them combined make 91. We know one of the angles is 69, and we want to find the other one. We're going to end up subtracting. Because the one we don't know plus the 69 degree angle equals 91 degrees. So yes, we will subtract 69 degrees. Bless you. And the measure of angle RST will equal 22. This one's only harder because the numbers aren't on the picture. So it's still the same thing. You just want to transfer all that you know. We want to find KLM. We know KLB is 26. And then we know BLM is 60. So then what are we going to do here? Add them. So the measure of angle KLM is 86 degrees. And then last, we want to find FGH. We were given FGB is 105, and BGH is 54. So what are we going to do with these two? Add them. Makes 159. Perfect. So you're going to take out the practice paper first. Let me go back and talk to you about one of them. You do not go past number 7 today because you'll probably do it wrong. So you can do number 8, but past that, don't do it because you don't know how to do the algebra yet. But I want to talk to you about these 4 first. All right. You're going to be identifying congruent angles, and so you're going to need to be naming the angles. Angle D, there's this angle. There's this angle, there's this angle. So can I say angle D to name the middle one? No. Okay. The same thing with angle A. You can think of angles like slices of pizza or slices of cake, depending on your preference. How many slices of cake are at angle A, or at A? 1, 2, 3. Everyone see? So you can't say angle A to name that one. Same thing at E. How many slices are at E? 3, and even if you counted the straight angle on the other side. There's too many. So all of these are going to be using 3 letters to name them, just for your heads up. Okay? So you're going to go through. You can go and do 1 through 8. Once you've done that, you can go back to the 1.4 practice and work on that.